What's up, Algebra 2? This is lesson 7.3. Go ahead and pause the video and try the warm-up. This is over lesson 7.2, which you should have just completed. Okay, here are the answers to the warm-up. Number 1 is 260 x squared y to the third z. Number 2 is 15 plus 4p over 5mp. Number 3 is x plus 11 divided by 6 times x plus 6. And it's okay if you didn't factor out the bottom. Finding the perimeter of the triangle, adding the three sides together. 25x squared plus 4x minus 2 times, or over x minus 1 times 2x plus 1 times 3x. No need to multiply that all together. And the least common denominator of these two functions is x times x plus 2 times 2x plus 3. So previously we have graphed polynomial functions. Now we're going to determine properties of reciprocal functions and graph transformations of reciprocal functions. So some new vocabulary. Feel free to pause and slow down if you need to. Reciprocal function, talking about vertical and horizontal asymptotes. Reciprocal function is something that looks like a fraction, 1 over a function or any number over some sort of function. So just some example of domains. If you have -3 over x plus 2, notice it's not defined at x equals -2 because that's what makes the denominator equal 0, and you can't divide by 0. Similarly, in this one, 4 over x minus 5, it's not defined at x equals 5 because 5 minus 5 is 0. That's going to produce an asymptote. And just 3 over x, well, that's not defined when x equals 0 because you can't divide by 0. So a hyperbola, the definition of a hyperbola is a specific type of graph. It's the parent function of reciprocal functions. It's the simplest one. F of x equals 1 over x is the simplest reciprocal function, and that produces a hyperbola, which has an asymptote, vertical at x equals 0, and horizontal also at y equals 0. So when you do 1 divided by something, or any number divided by something, you'll never get an answer of 0. You can get close to 0, but that's the definition of an asymptote. There are no intercepts. There's no x-intercepts. There's no y-intercepts since the function doesn't touch the x or y-axis. Also, domain and range is all real numbers except for 0. You could just say the domain and the range is, the domain is x can equal 0 and the range is y can equal 0. So let's see if we can determine the values of x for which this function is not defined. So think about what makes this particular function undefined. Well, remember, you can't divide by 0. So we're going to find the values for which the denominator equals 0. So we take the denominator, 3x plus 24, and we set it equal to 0. And then we solve it for x. We subtract 24 and get -24 and then divide by 3. You might remember opposite of the back divided by the front in a simple linear equation equal to 0. So x equals -8 is the value of x for which this is not defined. Let's see if we take a look at this function, if we can take a look at a graph and identify where are the asymptotes and then what's the domain and range. And typically where the asymptotes are will help you with the domain and range. So let's talk about vertical asymptotes. Where is x? Where's x values that you see that the function is undefined? So this looks like it's about, well, here's the function, 3 over x minus 2. Looks like right here, what value do you think this is where the graph breaks apart? X minus 2 can't equal 0, which means when x equals 2, this function will be undefined. So the function is not defined when x equals 2, so there is an asymptote at x equals 2. For horizontal asymptotes, from x equals 2, as the values of x decrease, the function values approach 0. So if you look at where x equals 2, we know that we're undefined here. But as x increases, where is this line going? Is it going all the way down to -infinity? No. It seems to be flattening out around 0. Same thing, as x goes to -infinity, the function seems to be approaching 0. So to find a horizontal asymptote, you kind of want to look at where is the function flattening out at? Or if you need to, turn your paper sideways or your graph sideways and treat it just like a vertical asymptote. I think you can see that this is breaking apart at the x-axis, so there's an asymptote when y equals 0. So asymptotes are when x equals 2 for the vertical asymptote and y equals 0 for the horizontal asymptote. So that means the domain is x cannot equal 2, or you can write it from using interval notation from negative infinity to 2 and 2 to infinity. And the range would be y can't equal 0, or using interval notation, negative infinity to 0, union 0 to infinity. So here's another function. This time we have 1 over x plus 2 and then plus 1 at the end. And you can see that kind of shifts the function up. We're going to talk about transformations of reciprocal functions next, but this is a good lead-in problem to it. So let's identify the x values for which the function is undefined. What value of x do you think would cause me to divide by 0 here and make this undefined? So it's x plus 2, which means x can't equal negative 2. That is the location of your vertical asymptote, x equals negative 2. From x equals negative 2 is the values of x decrease. Where's the function seem to be going? Doesn't seem to be going to 0 this time. It seems to be a little above 0. And this one seems to be going a little bit below 0. But if you think about the last few we saw, having horizontal asymptotes at f of x equals 0 or y equals 0, think about what this plus 1 does to the equation. It shifts it up by 1 unit. So this appears to be flattening out at y equals 1. So as far as asymptotes, there is a vertical asymptote at x equals negative 2 and a horizontal asymptote at y equals 1. And the domain would be x cannot equal negative 2, and the range would be y cannot equal positive 1. And of course, you can also write those in interval notation. Okay, one for you to try. Identify the asymptotes of the function. X equals negative 3 and y equals 0 are where the asymptotes are. And in letter B, try to identify the domain and range of that function. And before you do that, think about the asymptotes. But there's a vertical asymptote at x equals 4, so the domain is x can't equal 4. There looks like a horizontal asymptote at negative 3, so y cannot equal negative 3. So this is a lot of information on this screen here, the concepts of transformation of a reciprocal function. So if you remember what we have when we do transformations, you'll see the letters H and K. H is a horizontal shift. Remember that it's the opposite of what you see in parentheses. That still holds true. K is a vertical shift, shifts it up or down. That holds the same. A tells you whether it opens upward or downward, and B tells you whether it's stretched vertically or horizontally. So let's talk about graphing some of these functions. You're going to be asked to sketch graphs on your homework a little bit. So when you're asked to graph a function, the best thing to do is look at the direction of the graph, look at where the vertical and horizontal asymptotes are. From the last set of problems, I think you should realize that we're going to have transformations of a reciprocal. A is negative 1. So that means that it's been flipped upside down, reflected across the x-axis. And if you need any help, rewind and pause and look back at the last screen. H is negative 1, which means negative 1 is going to be where the vertical asymptote is. So it's been shifted 1 unit to the left because it normally was at 0. And then K is 3, which means the graph's been shifted up by 3 units, and that means there's an asymptote at y equals 3. So we can find the domain and range as x cannot equal negative 1 and y cannot equal 3, and then we can use that information. We can draw asymptotes at negative 1, and we can draw asymptotes at 3, and then you can draw a hyperbola in the reflected shape. If we go back here for a second, if you'll notice the regular shape of a hyperbola, has the part down here and then the part up here, and then whenever it's reflected, it's kind of flipped there. So try to pay attention to that. So here's another one that's been reflected. We have a -4 divided by x minus 2 plus 1. So where a is -4, so the graph is stretched vertically and then it's reflected across the x-axis. H is 2, so that means there's an asymptote at x equals 2. 2 minus 2 will give us 0 and make us divide by 0. And k equals -1, which means the graph has been shifted down by 1 unit. So domain is still x cannot equal 2. The range is still y cannot equal -1. So h and k are really connected closely to your domain and range. But a, if it's negative, just tells you to make sure you draw one of those backwards sort of hyperbolas. So let's take a look and see if you can graph this function based on your knowledge of transformations of the reciprocal. And the answer is B. Vertical asymptote at x equals 3 and a horizontal asymptote at y equals 3. State the domain and range of this function. Pause it if you need to. H equals -1, k equals -2, so the domain is x cannot equal -1, and the range is y cannot equal -2. So sometimes we can have real-world applications where we can write equations that end up being rational functions that involve dividing by an unknown quantity. A commuter train has a nonstop service from one city to another, a distance of about 25 miles. Write an equation to represent the time between these two cities as a function of rail speed, then graph the equation. So the formula we would use is rate times time equals distance, but we need time. So how do you find time? Well, to find time, you take the distance divided by the rate. So in this case, we know the distance is 25, so the time equals 25 divided by the rate. And if we graph that equation, it looks just like our parent function, going to have x can't equal 0, or in this case, r can't equal 0, and t can't equal 0. So now, let's explain any limitations to the domain and range of the situation. Well, the domain and range, if we say x can't equal 0 and y can't equal 0, doesn't make sense because that includes negative numbers. So we want to make sure that, in the real world, we restrict the problem to usually only positive values. So let's write an equation now. See if you can try this. When a commuter bus has a nonstop service from one city to another of about 76 miles, write an equation to represent the travel time between these two cities as a function of rail speed. 76 over r, very similar to the last problem, and it really doesn't matter what letters you use. And then which graph do you think represents that? Part D, Part A is similar to Part D, but Part D represents that it's a little bit steeper because it's been, 76 miles instead of 25 miles. Okay, that concludes the lesson. Good luck. You do not have to do the enrichment that goes with the lesson. Do the warm-up, do the Part 1 and Part 2 of the assignment, and the closure, and that will wrap it up.